Types of plastics. Plastic can be classified into two categories: thermoplastics and thermosetting plastics.
Difference between thermo and thermosetting plastic. Thermoplastics. These are formed by addition polymerization. These can be softened, reshaped and reused. These are long chain linear polymer with negligible crosslinks. Monomer used in these is generally bifunctional. These have low molecular weight. Example: polyethylene, PVC, PVA, etc. Thermosetting plastics. These are formed by condensation polymerization. They cannot be reshaped, reused once hardened. These have three-dimensional network structure with number of crosslinks. Monomer used in this is tri, tetra or polyfunctional. These have high molecular weight. Example: phenol formaldehyde, urea-formaldehyde, etc.
Thermoplastics. These plastics get softened when they are heated, and hence they can be molded into shapes. Once they are cooled, they become hard again. This process of softening and hardening can be repeated again and again because molecules in these plastics are always free to behave in this way. Polythene, PVC, polystyrene are a few examples.
Some of the common thermoplastics: HDPE, high density polyethylene; LDPE, low density polyethylene; LLDPE, linear low density polyethylene; ABS, acrylonitrile butadiene styrene; PVC, polyvinyl chloride; PP, polypropylene; polyamide nylon; PMMA, polymethyl methacrylate acrylic.
HDPE, high density polyethylene. High density polyethylene have straight molecular chains. This results in formation of a high density material. These are fairly stiff, strong and also quite tough. It can be softened at a high temperature around 120 to 130 degrees Celsius and are chemical attack resistant. Shampoo bottles, liquid soap bottles, detergent bottles are few examples.
LDPE, low density polyethylene. These plastics have side branches on the molecular chains which prevents close packing. As a result, these are less firmly attracted to one another and the polymer is weaker, softer and more flexible. This may be transparent or opaque. Low density polyethylene can be softened at low temperatures like 80 degrees centigrade. These are a few examples: dustpan, broom handle, bucket, bottles.
LLDPE, linear low density polyethylene. It is substantially a linear polymer. It has significant number of short branches, commonly made by copolymerization of ethylene with longer chain olefins. LLDPE has higher tensile strength, impact and puncture resistance. It is very flexible and elongates under stress. It has good resistance to chemicals. Used for plastic bags and sheets, plastic wrap, stretch wrap, pouches, toys, etc. Plastic packaging, carry bags, plastic stretch wraps, lightweight gallons are few examples.
ABS, acrylonitrile butadiene styrene. It's a polymer composed of 3 different monomers. The blend is made up of acrylonitrile, butadiene and styrene. ABS is an opaque thermoplastic. Excellent impact resistance, good machinability, excellent aesthetic qualities, easy to paint and glue, good strength and stiffness, and low cost. It is used in machined prototypes, structural components, support blocks, housing, and covers. These are a few examples: water bottles, computer mouse, watercolor box, auto urinal cleaning drip.
PVC, polyvinyl chloride. Polyvinyl chloride, PVC, a synthetic resin made from the polymerization of vinyl chloride. Second only to polyethylene among the plastics in production and consumption. PVC is used in an enormous range of domestic and industrial products. For example, raincoat, shower curtains, indoor plumbing, etc. It is lightweight, rigid plastic in its pure form, but can also be manufactured in a flexible plasticized form. PVC was first prepared by the German chemist August Wilhelm von Hofmann in 1872, but it was not patented until 1912. when another German scientist, Friedrich Heinrich August Klatt, used sunlight to initiate the polymerization of vinyl chloride. Bicycle mudguard, PVC pipes, PVC duct tape, coating on wire are few examples.
PP. Polypropylene. Polypropylene is one of those rather versatile polymers out there. It serves double duty, both as a plastic and as a fiber. As a plastic, it is used to make things like dishwasher-safe food containers. It can do this because it doesn't melt below 160 degrees Celsius. Polyethylene, a more common plastic, will anneal at around 100 degrees Celsius, which means that the polyethylene dishes will warp in the dishwasher. As a fiber, polypropylene is used to make indoor-outdoor carpeting, the kind that you always find around swimming pools and miniature golf courses. It works well for outdoor carpet because it is easy to make colored polypropylene and because polypropylene doesn't absorb water like nylon does. Here are a few examples: food containers, electric kettles, jugs, airtight containers.
Polyamide, nylon. Nylon is a man-made synthetic fiber identified with a number type 6.6 and type 6.10 for example. It is strong and very light in weight. Nylon fiber is very responsive and resilient as well as relatively resistant to heat, UV rays and chemicals. Used in clothing and fast-moving parts manufacturing like gears and bearings. Umbrella fabric, rain cover for bags, toothbrush bristles, nylon bags are few examples.
PMMA, polymethyl methacrylate, acrylic. Acrylic is a plastic manufactured using one or more derivatives of acrylic acid. Polymethyl methacrylate or PMMA is one of the most widely used forms of acrylic due to its exceptional strength, clarity, and versatility. There are a variety of acrylic polymer grades available for extrusion and injection molding manufacturing processes. Transparent, translucent, opaque, and colored polymers are available with varying lengths of heat resistance, light transmissions, impact strength, flow rates, and release capabilities. PMMA acrylic sheets exhibit glass-like qualities: clarity, brilliance, transparency, translucence, at half the weight with up to 10 times the impact resistance. Here are a few examples: safety glasses, watch glass, helmet visor, automobile lighting.
Some of the common thermosetting plastics: phenol-formaldehyde (PF), Bakelite; Urea-formaldehyde (UF), Melamine formaldehyde (MF), Melamine.
Phenol-formaldehyde (PF), Bakelite. The first plastic to be made artificially from chemicals was Bakelite. It is hard, brittle, and has a natural dark glossy color. Since it's a thermoset plastic, it resists heat without softening and is a good thermal insulator. At a high temperature, it will tend to char and decompose. Here are a few examples: suitcase handles, land phones, cookware handles, machinery knobs.
Urea-formaldehyde (UF). It is a colorless polymer. It can be further colored with artificial pigments to produce large scale of colored articles. It is a good insulator of heat and electricity. These are harder than Bakelite. Toilet seat, switchboards are few examples.
Melamine formaldehyde (MF). Melamine formaldehyde or melamine resin is a hard, very durable and versatile thermosetting plastic with good fire and heat resistance. It is made from melamine and formaldehyde by condensation of the two monomers. Melamine resins are used for the manufacture of many products including kitchenware, laminates, overlay materials, particle boards and floor tiles. Here are a few examples: cereal bowls, melamine polish,
Foamed plastics. Plastic foam is a plastic that has been frothed up during its molten state. then cooled. Foamed plastics are also known as cellular polymers or expanded plastics. All kinds of resin can be used as raw material for plastic foam formation. Synthetic resin, in the presence of auxiliary materials such as foaming agent, catalyst, and stabilizer, is heated to turn into a sponge-like mass with a closed cell or open cell structure, either of which may be flexible or rigid. Foam plastics has property of lightweight, heat preservation, sound absorption, and shockproof.
Some of the foam plastics: polystyrene foam, polyethylene foam, polyurethane foam.
Polystyrene foam. Polystyrene plastic is a naturally transparent thermoplastic. It is available in both solid plastic and rigid foam forms. There are two kinds of polystyrene widely used: expanded polystyrene foam (EPS), extruded polystyrene (XPS).
Expanded polystyrene foam (EPS). It is a lightweight cellular plastic material consisting of small hollow spherical balls. EPS is manufactured by expanding spherical beads in a mold using heat and pressure to fuse the beads together. EPS is shockproof, thermal insulator, lightweight, resistance to humidity, chemical resistant, and compression resistant. Extruded polystyrene (XPS). Extruded polystyrene has the same chemical composition as the expanded polystyrene, the EPS. XPS foam has smaller air pockets and is more uniform. XPS is manufactured in a continuous extrusion process that produces a homogeneous closed cell-crossed section. XPS has a high compressive strength and a superior thermal performance.
Now let's watch a lecture on expanded polystyrene foam (EPS).